impulse function or Dirac delta function. When you consider study of bending of beams, wherein point loads can be considered as much similar to large pressure acting on small area, we may make use of unit impulse function. First of all, consider a function delta epsilon t minus a, which has the definition. This displays the output 0 for values t less than a, and delta epsilon t minus a displays 1 by epsilon as the output for input values ranging from a to a plus epsilon, and delta epsilon t minus a displays 0 itself again for values t greater than a, where epsilon is a very small quantity. Here we have delta epsilon t minus a displays 1 by epsilon in the small neighborhood of a, and for all other values this function displays 0 as the output. At input values t strictly less than a and t strictly greater than a, the output is 0, and at the point t equals a and in the neighborhood of a, the function displays output 1 by epsilon. Consider integral 0 to infinity delta epsilon t minus a dt. We have this function delta epsilon t minus a has non-zero output only in the neighborhood of a. That is, integral 0 to infinity can now be reduced to integral a to a plus epsilon, because at t less than a and t greater than a, delta epsilon t minus a is already 0. So our integral takes the form a to a plus epsilon, and delta epsilon t minus a in this range, which is the neighborhood of a, is 1 by epsilon. So we obtain the integral a to a plus epsilon 1 by epsilon dt. After integration with respect to t, we have the integral reduces to 1 by epsilon upper limit a plus epsilon minus lower limit a, which equals 1. This function delta epsilon t minus a actually represents force acting for a short duration epsilon at time t equals a. Then we have the integral, which is the limiting case of delta epsilon t minus a, written as limit epsilon tends to 0 integral a to a plus epsilon delta epsilon t minus a dt equals 1. This is the new function which represents unit impulse function at t equals a. Or we have, since delta epsilon t minus a equals 1 by epsilon at t equals a, when you consider limiting case epsilon tends to 0, you obtain delta epsilon t minus a tends to infinity, because limit epsilon tends to 0 1 by epsilon equals infinity. Therefore, when epsilon tends to 0, this function delta epsilon tends to infinity, and at all other points for t not equals to a, this function tends to 0. Therefore, the limiting form of this particular function delta epsilon t minus a as epsilon tends to 0 gives us the definition for new function, which is unit impulse function or Dirac delta function. And we have the definition obtained as delta t minus a equals infinity for t equals a, and delta t minus a equals 0 whenever t not equals a, such that integral 0 to infinity delta t minus a dt equals 1.